Hey guys, welcome back to my channel. Um, Today is the extension of the heap chapter that we were studying yesterday. So we're gonna go further into it. Yesterday we have looked at the basic operations of the heap, min heap and max heap, and how we use it using the module heap from Python. Um, and we talked about stone clashing example from leetcode. So that was all basic simple operations. Today we're going to talk about the common interview question using heap, and one of its type is called top K. So basically, the interview question will do ask you to compute a question using involving some kind of um, top K most elements from the array or list or whatever data type. And yeah, so why would you use heap instead of iterating over the array and then counting the elements and um, picking out the most frequent element? The reason being that I'm going to share my screen. 1 second. I keep forgetting to share my screen beforehand. The reason being that if you iterate over all the elements in the list, the time complexity to pick out the k most element, kth most frequent element, is n times log n. So log itself is a very fast operation, but how would you improve it from here? It's by using a heap method. So heapify into a heap data structure and then basically pop left and then compute the top k elements. So that the time complexity of it would be n times log k. So the only difference here is that it's log k instead of log n. And since n is the length of the array, k logically and naturally should be always smaller than n. So, and this is not really a big difference compared to, for instance, using hash map from um, iteration. 1 second, my webcam is. I think it's better if I change to the integrated camera. So I'll just quickly do that. Oh no, it's working. Yeah. So it's a very small difference, small improvement, but it's still an improvement. So that's what interviewers ask for in the interview. And this is what I've read because, yes, I've never been asked heap in my interviews before, and I'm trying to prepare myself, and it's good to know. So, and it's easy to implement heap um, as long as you understand the mechanism of the question. So let's just dive straight into the question and then see see if we can do it. So the question is, this is medium level difficulty, top K frequent elements. So the basic example that I've explained while while going through the this interview type. So given an array nums and an integer k, return the k most frequent elements. You may return the answer in any order. So from this array, we're trying to find the two most top frequent elements. So you can see that I is one is occurring 3 times, two is 2 times, three is 1 time, top two is 1 and 2. So that's why there's 1 and 2. From example, test case 2, there's only one element and k is 1, so naturally it's 1. Sorry. So the logic is clear. So how are we going to use the heap method? Let's go to um, a Word document and list out things that we have to do. This was part of the my teaching because I sometimes do part-time freelance job and teaching English to kids. But anyways, okay. So first of all, we would have to count the frequency, right? Um, we would have to count the frequency, how often each element occurs in the input list. So that part is same as just normally iterating through all the elements. Um, although we can use a basic counter module from Python here. Second is, like always, when doing the heap question, we're going to initialize min heap. So we need to initialize min heap. So it will be an empty list of heap so that we can put min heap in it. Since it's not a max heap, we don't need to do the negative operation on it. Third one is actually populating, filling up the heap, heap, not heat. So we iterate through each key value pair. So it's going to be provided to us in a tuple. Not provided to us, but we make it into a tuple. So it will be frequency and then elements. And we're going to use the heap push from Heap II module to push it just like the normal queue. And then while we're doing that, after doing that, we're going to ensure that the heap size does not exceed k by removing the smallest element using the heap q module pop left, not pop left, just heap pop method. So from the total number of frequency, we're gonna subtract it by using the heap pop, and then we're gonna do that until um, it is lesser than the k, right? Um, so that we find the top k elements, top k frequent elements. Yes. And we're gonna finally extract top k elements. We're gonna use list comprehension for this. We're gonna extract the elements from the heap and return them. So now that we have it, let's dive into coding. So for starters, we would have to count the elements, right? So how would we do that? From collections, we import the counter, and we also import the heap queue because we're going to use it later. We're going to put it, oops. Yeah. So nums k and we have it. So counts is equal to counter nums. So we create a dictionary. This counter creates a dictionary, counter on nums, create a dictionary where keys are the elements from the nums and values are the respective of their uh, respective counts. So it automatically creates a dictionary. So it's very convenient. So for example, if the count is like 1, 2, 2, 3, like in this test case, then the counts will be 1, 3, 2 and 2, and then 3 is 1. Now we're going to use the min heap. initialize the min heap. So heap equals empty list. Now we populate the heap, right? So we're going to iterate through the dictionary file in counts items. Oh, fuck the screen. Just 1 second. Yeah. It's really inconvenient that I have to plug it out and then plug it in again. This laptop is shitty, this webcam is shitty, and nothing is working. Anyways, yeah. So after this, we push the elements into the heap, right? And we use that using we use the heap push. So heap q dot heap push, then push the value and its key. And when we're doing this, if the length of this heap is more than k, because we're only trying to like I said, we're only trying to find the top k most populating elements. We're gonna pop the elements from the heap. So that should be done by heap pop and heap. And now we return the list comprehension. Oh, just 1 second. Yeah, to extract the top k elements. And that should be return pair I for pair in heap. So this will extract the second element of each tuple, which is the original element, and return it as a list if the k is 2. So yeah, I guess hopefully this works. Runtime error. Cannot import name counter. I is not. Oh, when did I say I? 1. Yeah. So guys, we can see that it's returning the top 2 elements, and same goes for case 2 when the k is 1, and it just returns the top most populating elements. So yeah, that was it for top k elements. We have way more examples on each of these types, but I'm just speed running through the basics so that later when we go through all the algorithms, we can come back and then really dive into it. Because now I feel like the acquiring the background knowledge is more important. So yeah, and if we do certain examples from each algorithm, there's a big chance that we're going to forget when we move on to the next one, and so on and so forth. So yeah. Anyways, that was it for today, guys. I don't know if there's more to go over in Heap, but if there is, then I'll study it tomorrow and then share it with you guys. Um, or else, I think we're moving on to the binary tree. Not sure, but I'll let you know tomorrow. Thank you guys all for listening, and see you guys